Hey. Okay, so we are starting IRT or item response theory. And this is a way to look at it's a set of latent variable techniques, and then they're designed to model interactions between a participant's ability or their latent trait and then against item level stimuli. So this can be like difficulty guessing, etc. And so the focus is on the pattern of the different responses versus the composite variable that they look at kind of in classical test theory. So this emphasizes how responses can be thought of in probabilistic terms. So we're starting off and doing a one parameter logistic model, or a 1PL. It's also called the Rasch model. And it describes how test items in terms of only one parameter. So looking at item difficulty in this case, or beta, and shows us how hard or easy an item is, and then determines how high the latent trait ability level needs to be in order to get a 50% chance, or in order to have a 50% chance of getting the item right. So I used a really small data set. I just did 6 items and 6 people. And I coded 1 for correct answers and then 0 for incorrect responses. So either yes or no. So I installed and libraryed the package LTM. You need to run this. And then to start out, I'm going to fit the Rasch model to the data. So this estimates the item difficulty based on how people answered the item. So their correct and incorrect responses. Oh, I didn't import my data. Hold on. All right, here we go. Okay, cool. So then you can run the model summary of this, and this will give us information like difficulty, standard error, z-values. So if we look at the different items, we can look at the different values to see see the difficulty parameters. So z-values that are higher than 1.65 supposedly indicate that the difficulty parameter is significantly greater than 0 at alpha 0.05. So higher difficulty estimates indicate that the item requires a higher ability, a higher level of the latent trait to have that 50% chance of getting the item correct. So we can look at our values over here. None of them are too high. We have one that's not, it's not a good fit. We'll figure this out later, but you can look at just the difficulty across the items and the discrimination between the items. And you can get estimated item parameters, very similar. And this gives us the different descriptives and shows the proportion of the people who got the items correct. So once again, different items, the difficulty, the discrimination. And then we can plot the model by item, so we can get a visual representation of all of this. The item characteristics curve shows like the probability and the ability. So we want to run that. And so a couple of mine, as you can see by the values, had the same difficulty values. So they're going to be shown on the same line. So numbers 6 and 4, this pink and this blue are the same. And then items 1 and 3. So 3 and 1 are also the same. So this green line, so this pink line and the green line are actually showing the same, showing 1 and 3 and 4 and 6. Didn't feel like going to change it. Probably should have. It would have looked a little bit different, a little bit better. So basically, we're plotting the model by item, like I said, and this is called the item characteristics curve. It shows us the probability and the ability. So the latent trait or your ability is plotted down here on the x-axis, and so higher values are going to represent higher ability, and then obviously lower represents lower ability. And then the probability of getting a correct answer to an item is plotted across the y-axis. So remember, we're looking at this point of 0.5, 50%. And then, so the most difficult item is going to be the farthest right in the plot. So we're going to look at number 1 and number 3. The slope over here is the farthest. And then the one farthest left is going to be the easiest. And you can match these with those values that we kind of looked at before to determine the level of difficulty. So we see the negative values, and then the higher positive values are going to determine if it's more difficult. All right, next, we're going to plot the item information curves, and so this will give us more information about the latent trait abilities for each item. So the curves will peak at the difficulty value, so that's considered the point of highest discrimination. And then as the farthest gets away from the difficulty estimate, so that high value, the less information we receive. So with this, we can see how difficult the items, how really difficult items are not going to provide as much information about a person with a really low ability because the item's already too hard, and then it's fairly easy and then very easy items will provide little information about people with higher ability. So a really good example is this red line here. I don't remember what one that is. Item 2. Because no matter what your ability, there's no differentiation. So we can look at, so like I said earlier, the number 1, number 3, this green curve, the peak point is about 1, and then 4 and 6 is probably about -2. So this was the easier of the two that we looked at for easy and hard. So this is the easier question. This is the higher. The probability of getting this one correct is higher at a lower ability. But once again, so the way it slopes out, we can determine how much information we receive about the different abilities. So next, we're gonna do basically a summation of all of this. This is the sum of all of these ICCs, and then so this is a test information function, and so this will give us the overall information about ability level from the collective of those items. So the peak, once again, shows us where the test provides the most information about ability level. So this is just probably slightly above 0, I'm going to say. However you want to interpret it. It's around 0. I'm going to say slightly above. So you have slightly higher than 0 ability in answering this for the entire test. And then this last one is to look at item fit. So you look at the p-values to determine overall fit of the items within the test. And smaller p-values are going to indicate that the items do not fit the model well, and different IRT models should be considered when looking at how to differentiate these items. So here we can look at our different p-values. Items do not fit the model. But basically it's used to see how well the fit for each item matches up with the others. So for the overall test. All right, bye.